This video picks up where we left off in the last video. If you recall, in the last video we were looking at finding integral and fractional expressions where we had a numerator degree that was larger than the degree in the denominator. And when we had that, we did long division. In this case, what we're going to look at in the examples in this video is when the degrees in the numerator are less than the degree in the denominator. And what we always want to do then is break up that fraction, that p of x over q of x, into a sum of forms that have a linear factor in the denominator. So ax plus b, that's linear. And notice when you have an ax plus b factor, the numerator is always going to be a constant, if you will. And then we could also have quadratic factors. So when you have a quadratic factor, you'll notice that, it's quadratic in the denominator, but in the numerator, it's always linear. So without any more talking about it, let's just see how this works. So it says in example 2, it says use partial fractions to evaluate the integral, and then you see it, and it looks like this is quadratic, right? But if you can, you definitely always want to break it up into linear factors. And you can in this one because this one is factorable in the denominator, right? So the x squared minus 3x plus 2 is equivalent to this x minus 2 times x minus 1. And so that's a product of linear factors. And so the way we would rewrite this is as a sum of partial fractions. So since they're both linear, each one of those denominators, the first one being x minus 2, and the second one being x minus 1, each one of those is going to have a constant in the numerator. So it's going to be a over x minus 2 plus b over x minus 1. And what we always want to do is once we have done that composition or decomposition, then we want to multiply both sides by the least common denominator. Let's go ahead and make a note of that. Multiply both sides by the least common denominator. Which of course in this case would be x minus 2 times x minus 1. So when we do that, when we multiply both sides by the least common denominator, the left side is going to be x plus 3, and then the right side is going to be a times x minus 1 plus b times x minus 2. And now the goal is to figure out what those constants a and b are. We got to figure out a and b. So there's really two different methods that we can go ahead and look at to figure out what a and b are. Okay, so the first method that we're going to use is the one that I'm going to use mostly, but I will show you the other method, is we're going to take this identity that we just created, and we're going to exploit the fact that this identity is true for all values of x. So think about real quick, what are some values of x that would be nice to plug into this identity that I just rewrote, that when you plug it in, it makes the equation a whole lot more simple, right? I can think of two right off the bat that are going to drastically decrease or simplify this equation. The first one I would think of is x equals 1. Because when you plug x equals 1 in, what do we get? Well, we get 1 plus 3, which is 4 on the left side. And then on the right side, when you plug 1 in the first part, 1 minus 1 is 0, the a part completely goes away. And then we have plus b times 1 minus 2, that's negative 1. And so that actually tells us what b is. That tells us that b is equal to negative 4. Okay, so that was pretty simple. We found the first constant. Can you think of what would be another nice x value to pick? Yeah, absolutely. X equals 2 would be good. And so when you plug x equals 2 in, we get 5 on the left side. 2 plus 3 is 5. And then when you plug 2 in here, we have 2 minus 1 is 1. So we have 1a. And then again here, because we picked x equals 2, the b disappears. And so we just figured out what a is equal to. So that's the first method. The second method, which takes a little bit longer, I know some people do like this method, is we still use the identity that we created. We still have x plus 3 equals a times x minus 1 plus b times x minus 2. But what we're going to do is solve a system of equations that results from that identity. And in order to do that, we need to kind of rewrite this identity. So if we distribute the a and the b in, we get ax minus a plus bx minus 2b equals x plus 3. And then we're going to go ahead and group like terms together on the right-hand side. So left side, let's leave it as x plus 3. But on the right side, we have x terms. The x terms look like ax plus bx, and since they both have x in them, we could factor the x out, and so that would look like a plus b times x, and then we have our two constant terms, which look like minus a minus 2b. And it probably is actually even better, so let's go ahead and rewrite it like this. So let's say plus the constants, and the constants again are minus a minus 2b. And then we just kind of compare things up. So if you look at the left side is also in linear form. So x plus 3, that's linear. And then the right side is linear form. It's a plus bx plus the constant. And so what that tells us, if we're comparing the left side with the right side, that tells us that the constant in front of the x over here, which is 1 has to be equal to a plus b. Because, again, this is like 1x. So 1x has to be equal to a plus b times x. So 1 has to equal a plus b. And then the constants, it has to be true too. The 3 on the left side has to be equal to negative a minus 2b on the right side. And then you can just solve the system of equations, right? So I'm noticing right off the bat here, I have a positive a and a negative a. So if I use the elimination method and just add these two equations together, I get 1 plus 3 is 4. A minus a cancels, and then we have b minus 2b is negative b, which of course means b is negative 4. The same solution we got on the other side. And we can go ahead and plug that in to one of these other equations. So we have 1 equals a plus b, which means 1 is equal to a minus 4, which means a is equal to 5. So we got the same two answers. Again, you'll notice the method on the left required much less work, which is a good thing, right? So let's go ahead and now rewrite this integral. Again, the integral had the form a over x minus 2 plus b over x minus 1. So this is equal to the integral of a, which was 5, over x minus 2 plus b, so minus 4 over x minus 1 dx. And we already saw how simple that is to evaluate, right? It's actually the integral that we did in the warm-up. So we know that this is equal to 5 times the natural log of x minus 2 minus 4 times the natural log of x minus 1 plus c.